In section 1.3.3, we will learn about two special cases of lines, vertical and horizontal lines. These two lines have a special form. Let's draw a picture to get a visual of these two special cases. I'm going to set up my axes. X is always horizontal and Y is vertical. A horizontal line looks something like this. It moves left and right, and a vertical line goes up and down. You can remember this by thinking about when you look out on the horizon at the sunset. The horizon is flat. It moves left and right. Vertical lines move up and down. Horizontal lines have a slope of 0. Notice in a horizontal line that there is between any 2 points a run value, but there's no rise between those 2 points. So the rise is 0 even though there is run, which causes horizontal lines always to have a slope of 0. Ordered pairs always have the same y value. So looking at our example graph, let's suppose that this is y equals 2. Then both of those points would have the same elevation or same y value. X is going to have a lot of different values along that line, but y always stays the same. Therefore, the equation of a horizontal line is always y equal to some number c, where c is any real number. So horizontal lines have a slope of 0, and the form for the equation of a horizontal line is always y equal to a number. Vertical lines, on the other hand, have undefined slope. So if I consider any 2 points on a vertical line, there is definitely rise between them, but there is no horizontal run. There's no horizontal change between those two. If you'll remember, that slope, m, is rise over run. If we have rise but 0 run, then we're looking at dividing by 0, which is an undefined operation. So in general, we say vertical lines have an undefined slope. Ordered pairs will all have the same x value. If I look at any 2 points on a vertical line, the x values don't change even though the y values do. The equation of a vertical line is always x equals a constant, where c is some real number. So horizontal lines have the form y equals c. Vertical lines have the form x equals c. It's important that you learn this now. Later on, when we study rational functions, we'll be writing the equations for vertical and horizontal asymptotes, and we'll know very solidly at that point that a horizontal line has equation y equal to a constant, vertical lines x equal to a constant. So let's try some applications. Example 4. Write the equation of the line that has the properties described in each problem. A. The line passes through ordered pairs 7, -1, and 7, 3. Now compare those 2 points, and what sort of observation could you make about those 2 points? I bet that you noticed they have the same x value. Your brain is drawn to that pattern, and it's easy to observe. So these 2 points have the same x value. Well, if x is constant between those 2 points, then we could say x is always equal to 7. This is a vertical line. Example B. The line passes through 5, -2, and -1, -2. Again, looking at those 2 points, what catches your eye? Did you notice that they have the same y value? If they have the same y value and y is constant, then we know we're dealing with a horizontal line. The form for the equation of a horizontal line is y equal to a constant, and in this case, it's y equals -2. Example C, the line is horizontal and passes through 3, -4. Well, if the line is horizontal, we automatically know the form for the equation should be y equal to a number. So I'm just going to identify the y value in this ordered pair, and that indicates y is always equal to -4. And finally, the line is vertical and passes through ordered pair 611. If the line is vertical, then the form should be x equal to a constant. So I'm just going to identify the x value of the ordered pair, and that tells me what constant I should use in the equation x equals 6. So make sure that you memorize horizontal lines have the form y equal to a constant, and vertical lines have the form x equal to a constant.